चलिए सो ये हो गया था TCP IP. Okay, so till then we have done with Wi-Fi, HTTP, sorry, not HTTP but MQTT, and now we are going to start TCP IP and WebSocket. So what is TCP IP? It stands for Transmission Control Protocol, and in short Internet Protocol also. So it is a foundation of all internet communication. Every protocol we have learned, HTTP, MQTT, WebSocket. स्क्रीन शेयर नहीं है. Okay. Is it visible? No. So it is a base of every communication protocol like HTTP, MQTT, and other WebSocket, right? So it runs on the top of TCP IP. It is the base level of communication protocol. That means in which we are directly dealing with the actual server address, right? So that means it is also known as the lowest level communication protocol, right, to transmit the data, right? So TCP provide a reliable, order, error-checked stream of data between two devices. Once a TCP connection is established, both sides can send data freely in both directions. Right. This is the basic difference between TCP IP and HTTP and MQTT. Like HTTP, the direction based, right? Client request only, right? Whenever the device will send one request to the HTTP server, it will give the data, right? And MQTT work on public subscribe method via broker, right? And TCP IP both directions simultaneously. That means kind of you can assume it as a pipe to transmit the data, right? The pipe that we normally use to transmit like as a water, right? So from both sides we can transmit the liquid, right? So in the same direction we can also assume the TCP IP. So in HTTP we need to host one server and we need to have one dedicated broker, right? As a in MQTT we need as a dedicated broker for that, right? In HTTP we don't need that, and in TCP IP we don't need any broker or any mediator. We can directly communicate with through the given address. And this is we talk about overhead. The HTTP has little bit higher, larger header, and it is MQTT is low in a small header, because it's lightweight. And in HTTP it is also lighter than even MQTT, minimum raw data only, right? So here we're not sending any format or anything, we are just transmitting or exchanging the pure data, right? The use case for HTTP is like web pages, REST API create karna, and MQTT use case like IoT and telemetry command, and TCP IP used for industrial and custom protocol, right? If you want to design any kind of with our custom security, then we can build the top of TCP IP communication protocol. And control limited by HTTP protocol, right, and limited by MQTT protocol. But TCP IP give you full control to define the protocol. That means we can customize our communication protocol according to our requirement. And if we talk about the complexity, HTTP is fine, little bit simple, and MQTT is moderate kind of thing, and TCP IP is more simple than both communication. So there is two things in TCP IP communication: TCP server and TCP client, right? So like we can define first of all which kind of like any device we can define as a client, or any device we can define as a servers. But the difference between the server and client is like a server will be listen on a port. That means server will always listen that is there any data on any specific port, right? And client must have the server IP address and port to transmit that data on the same path, right? And server will wait for the connection until the connection will not establish, server will not respond, right? And client will initiate connection, and then server will accept that connection, right? And except when client connects, send request on data, right? First of all, TCP when send connection request, then server will accept that request, and then TCP client can send the data. And server will handle communication like any kind of operation over the incoming or outgoing data. right? And as a client only receive the response from the server, right? This is the connection sequence. That let's say we have developed one Python application and it is connected with through IPN port, and ESP32 can request, we can directly either request for data from the ESP32, or we can ESP32 can request data from another one. That means we can configure our device or our application according to our purpose, that we want to keep it as a server or as a client. Okay, so TCP like is a phone call. You dial a number, connect to a specific IP address. The other side pick a server accept. Right now, both can talk freely. The lines stay open until someone hang up. MQTT is sending WhatsApp message through a server. TCP is like a direct call on a no mediator, right? So we'll make one project here, right, through the TCP, and for that, first of all, directly start with the we'll start from the ESP32 side, right? And in that we will make our ESP32 as a server, TCP server. Okay, and this is the code available for to create the ESP32 as a server, right? And it will give us one IP address, and we'll try to communicate over that IP address through the mobile app, right? So either we can create our own client using the coding like Python, Flutter, or web based, right? Or either we can use any ready-made application. So for testing purpose, we'll just use one basic ready-made mobile application. I will give you the link of it, right? You can download that. But before that, feed this code, create a new project with the name of TCP ESP32 to TCP server. Okay, paste this code in that module and run it, and feed into the ESP32. Do not forget to update cmake_file.txt. Either you can connect with a Python, or we can use any mobile application. So this time, to save the time, let's use them directly in mobile application. Okay, so I have, first of all, let me open that same project here. So as you can see on the terminal, it right, there is one IP address. It has given that this is the IP address, and we can access this IP address through the applications. Okay, so in a mobile I have one application. Okay, let me try to join through mobile first. My screen is visible. Okay, so let me open both at the same time. I think only one screen is visible here. Both screens are visible, right? PC screen also should be visible, right? So let's say first of all how I'll connect. I will go to the setting and TCP setting. I will first enter the IP address, right? So in that case, what is the IP address? 10 right dot 195 dot 235 dot 252, right? And what is the port number? It's 4 times 3, right? This is the I have saved in the setting. Now I will go back to the application and I will click here and connect, right? It is saying connected, right? Now I will, let's say I am saying I want to send something here from LED dash off on okay, LED on, right? So I got here message acknowledge LED on, right? In a similar way I can send other message like LED off or whatever you want to send and to accept that command, right? But I think it is say that unknown command because I did not handle that command, and that we can understand through the coding part. Okay, so let me share you the link for this application with you. Okay. I have sent directly APK. You can download that. Or the name of the TCP client, you can also search on Google Play. No worries. So yeah, let me explain the code little bit. So we have started code from main.appman, right? And here we have initialized some basic our GPIO pins, and then we initialize our flash memory. Then we have initiated our Wi-Fi, right? Wi-Fi is compulsory, and here we have created one task. Name is a TCP server task, right? So in the task, first of all, we have initiated by allowing our server that to listen at the specific port, right? So if there is a listen socket, like at which socket it will listen, that we have given some parameters here, right? So these are just like pre-built setting, right? These are the ready-made function and ready-made setting, like you can assume it as a configuration to set up a server, right? And after initializing all this connection, IP address, family and port, right? And if it is connected successfully, then we are printing log, and in a while loop here we are accepting the messages, right? That means the server in the listening mode. So if it is receive any command, right, anything from the client side, so it will give us data as a RX buffer, right? So that means here this is the socket, and in the RX buffer we will receive the data through this static function, right? And then we will first of all we will remove the unwanted character like /n/r from the code, and we'll directly try to fetch exact message that we want to compare here, right? So let's say we have received LED on, and we are compared to the string comparison function, and according to the command LED on LED off, we are taking the action here like toggling the GPIO pin and sending the response, right? So these are the, I think, very basic functionality, and yeah, you can customize according to the project level requirement, right? What we want to take as an action here. We can display the data over the LCD, or we can send somewhere else, right? या तो इतना ही था इसके अंदर, राइट? सिंपल सा है कि अब जो भी डेटा आ रहा है TCP IP से, वो आपको यहाँ पर शो करके उसको यूज़ करना है टू टॉगल सम काइंड ऑफ पेरिफेरल्स ऑफ ESP32. ओके ओके, इनिशिएट करो प्रोजेक्ट को. हो गया, मतलब किसी को हुआ अभी तक? एक बार ट्राई करना आप सभी को ये प्रोजेक्ट, ठीक है?